Hello everyone, welcome back to the Genomics Bootcamp. This time with a quick summary of the three of my favorite R functions and why I like them. I will give these three functions in sort of a timeline how I discovered them, but while you are listening to this, feel free to jot down your favorite R functions in the comments below. But let's get to it. My first favorite R function pair actually is the Manhattan and the QQ functions. Well, I have quite a personal reason why I like these. They fill me with a bit of a nostalgia, as these are the first specific purpose R functions I remember using. You see, back in the old days of 2010, well, it was not so long time ago, but still, the place where you could find these particular functions were on a specific blog. Now it's discontinued, but still there, the Getting Genetics Done. And since it is still online, let me show you how it looks like. So this is the blog of one and only Stephen Turner. You see it was running until 2017, but this particular entry is from 2010. And well, this contains the source code of the R function Manhattan. So if you just scroll down a little bit, there were some pictures here, which is now not really working. But yes, so this is then the code for the Manhattan function that is now in the cron repository. But now it's, you see, there are many, many lines of code. And back in the days, we just basically copied everything and, well, just used it as an R function ourselves. Now it is quite an easy solution, as it also mentions here, update from 2014. Now it's available as R package. Actually, this is also out of date because not just from GitHub, but also from cron now, as I will show you in a minute. But anyway, just a quick side note, this blog is quite interesting. So if you're interested in genetics, I recommend you to browse through all of these entries and maybe you find something interesting. So back to R here. So we need to load this package now because, as I mentioned, this is available via cron now. So you can install it via install packages, QQman, and then load it with the library QQman. And there is also a citation here that you should use whenever you use it in your papers. Also, it comes with a neat data set, the GWAS results here. So I just run the GWAS results. So just to show you how this data set looks like. And it is indeed a simple one with a GWAS output with a SNP ID, chromosome, base pair. Well, now it's just a consecutive number, but still the kind of a base pair position and the p-value for the significance of that particular SNP. And if you want to do a Manhattan plot, you have to do only one thing, just say Manhattan, and then inside the brackets, the data set that you want to plot. You execute the function Manhattan with the input data set of GWAS results, and you get a readily made Manhattan plot with all the chromosomes and also some lines for the significance thresholds. Of course, you can adjust everything from these thresholds to colors, pretty much everything that is available in ggplot. Also, it is very useful to know the QQ plot, so the quantile plot, and you can use this or you can get this with the QQ function. And then if you run that, you get the QQ plot for your particular data set. And of course, you can use the information from this plot also in your future research. So as I said, Manhattan and QQ, for me, nostalgic reasons, but also very useful and very easy to use. And actually, the usefulness and ease of use will be a returning theme in these favorite R functions. The next favorite R function I want to talk about is actually also a pair of functions. It is the pivot underscore wider and the pivot underscore longer functions. These two are functions for data modification. To be honest, I do not need them many times, but when I do need them, they save me a lot of time. Basically, what they do is they transform an R dataset from many columns to a single column, or vice versa, from a single column R dataset back to many columns. I will show you in a minute what I mean. But the reason why I like these two very much is that, well, before, when I did not know about them at the beginning, I did attempt to code this myself. So basically, I needed to rearrange data sets like this. And well, since I haven't known any better, I tried to code it myself. And I know it takes like a lot of time to get something like this in a working state. Now that I know about them, I can appreciate very much the sleek design and the use of these functions, and again, the time that they save for me. So for the demonstration of pivot underscore wider function, we will use the fish encounters dataset. It is basically a dataset that tracks the migration of fish along the river. So it has 3 columns. The first one is the fish ID, the second one is the station, and the third one if it was seen at the particular station. So you see there is multiple lines for each fish. Now, if our goal would be to have a dataset that is 1 line per fish, and then the columns should be the stations, we could use this, or we can do this very easily with the pivot underscore wider function. We take the names from the station, so these will be the column names, and the values from the scene, so if it was seen or not, and we just run the pivot underscore wider function, and it transforms the data for us to this format. So wherever it was seen, there is a 1, and whenever it was not seen, because also that happens, there is an NA and 1 line per fish. So it was previously a long data set, and now it's a wide data set with many columns. Well, sometimes you might need actually the opposite thing. So you have a data set with many columns, and then you want to get it into a long format. And well, while we could use the fish encounters dataset, we will not use that, but we will use the billboard dataset, which is actually also quite an interesting one, from billboard charts from various singers and what were their position for a particular track. Now you see here is each artist have a 1 line, and then the position on the billboard for particular weeks, for a number of weeks. And if we want to change this wide format to a long format, then we use the pivot underscore longer R function. There is a bunch of other things you could set, but basically if you run that, so you can have, instead of this wide format, a long format with the rank for a particular weeks in 1 column. And last but not least, my most recent love when it comes to R functions, the ggsave function. I like this function very much, mainly because how easy it is to use and how versatile it is when it comes to saving figures in a PNG, JPEG, PDF, and many other formats to your hard disk. Again, it is the ease of use and usefulness of the function I like very much. Well, in particular, I remember my past struggles with changing figures to meet the specific DPI, so the dot per inch resolution criteria of various journals. And well, I know it could be sometimes a struggle, but now it is very easy to use and very easy to do this. You just use the DPI function argument or setting, and basically you are all done. So by default, it actually takes the last plot that it was created in R. So here I have just the example of a plot from a fuel economy dataset. It could be actually any plot, but basically it takes the last one by default. And if you want to save this plot on your hard disk, you just have to say ggsave and actually just to give the name for the file. Of course, if you want to specify certain other requirements like size of the picture or DPI or some other requirements, you can do it very easily directly from the function itself. So if we run this, it actually just saves this on the hard disk and you are all done. So these were my personal top 3 R functions at the moment. Let me know in the comments below which one are yours. I would be frankly very interested in these because, well, I'm always on the lookout for new ideas and new approaches. And of course, if there is an interest for this, we might do a follow-up video on the favorite R functions as well. For now, I want to end it here. Thank you for your time, and I wish you a very nice day.